Today we are going to solve our next question on LeetCode. The question is rotate array. So let's try to understand this. So it is saying that we have given an integer array nums and we have given an integer k and we have to rotate this array by k steps and we have to rotate it at right. And it is given that this k is always non-negative. So let's try to understand this with the help of this example. Before that, let's see this follow-up. It is saying that try to come up with as many solutions as you can. So there are multiple solutions available for this question, and we will try to see up to two or three solutions of this problem. And you have to perform this in place with O of one extra space. So basically, you have to solve this question in constant space complexity. So let's go and try to solve this. So here we are taking this example to understand this. So let's start with the first approach. But before going further, uh, I want to make a statement here. And the statement is that rotate this array by k, rotate this array by k steps is equal to rotate this array by k modulo n steps, where n is the length of this array. So n equal to nums dot length. So why I'm saying this, let me prove this. So here in this question, k is given as 3. So as we are saying that rotate by k steps is equal to rotate by k modulo n steps. So here k is equal to k modulo n simply. So if you will try to rotate this by 3 steps, it is similar as we are rotating as k modulo n, that is the value of k here is 3 and modulo 7. The length of this array is 7. So 3 modulo 7 is equal to 3. So basically rotate it by 3 and rotate it by 3 modulo 7 is basically equal. So let's try to rotate it by 3 position. So when we will rotate this array by 3 position, then let's start from this last index. So we will rotate this 7 for 3 times. So for the first time, it will come here at this place. For the second time, it will come here. And for the third time, it will come at this second index. So basically, we will simply put the 7 here at this place. Similarly, this 6 after rotating for 3 times will go here. This 5 will go here. And similarly, this 4, when rotate for 3 times, 1, 2, and 3, it will go at this place. Similarly for 3, 2, and 1. So this is the result after rotating this array for 3 times. Now let's say question is saying that you have to rotate it for 10 times. The question is saying that here k equal to 10. So you have to rotate this array by k times. Now what we will do, we will try to do k equal to k modulo 10. As we have made this statement here, so let's try to do this. So k equal to 10. So 10 modulo, it is not 10, it is n, that is number of length, number of this element in this array, means the size of the array. So it is k modulo n. So let's try to perform this mode operation with the length of this array. It is 7. So 10 modulo 7 is equal to 3. So if we are rotating it for 3 times and if we are rotating it for 10 times, the result will be similar. So let me prove this. So let's say the key is given as 10. So we have to rotate it for 10 times. So let's start from this last index and try to rotate it for 10 times. So after the first rotation, it will come here. Second rotation, 3, 4, 5, 6, 7. Again, it will come here at 8, 9, and 10. So finally, this 7 will come here after 10 rotations. Similarly, this 6 will come at this position. This 5 will come at this position. And this 4 will come at this last position. As we can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So after 10 rotations, this 4 will come here. Similarly, this 3, 2, and 1 will come here. So this is the result which is similar as the previous result when we have to rotate the array for 3 times. So it is so this is proving that if we are rotating the array by k steps, or if we are rotating it by k modulo n steps, so it is basically the equal number of rotations. So this is the first conclusion that we have made out of it. Now let's try to solve this. So the first approach we are going to use, here we are making it time efficient. So what we will do, we will take an extra array to solve this. Let's say this we have taken this dummy array, and this will be equal to the size of this nums array. So now what we have to do, let's say k is equal to 3. That means we have to rotate this array by 3 times. So what we will do, n is equal to nums dot length. So we will start from this position n minus k. If we will write index 0, 1, 2, 3, 4, 5, and 6, then this n minus k is equal to n minus k is basically equal to 7 minus 3, that is equal to 4. So basically we will start from this fourth index. So we have to start from this fourth index. After that, what we will do, we will take another array and we will take a counter here. Initially the value of the counter will be 0. So what we will do, we will simply take this element from here and put it at this 0th index. So 5 will come here. After that, what we will do, we will simply increase the counter and increase this pointer and also increase this counter. After that, again we will at this position at index 5. So we will take this element and put it at this place, increase the counter, and simply increase this pointer. Again we will take this element and put it here, increase the counter, and increase this pointer. Now as this pointer is exhausted, so it will terminate out of the loop. We do not need to move further. So what we will do now we will start from this first position and we will take another pointer here. And what we will do, we will simply take this element and put it at this place and increase both the pointers. So here we will increase this. After that, we will add two position first index. So we will simply put that two at this place and increase the counter. Also increase this pointer. After that, again, we have to take this element, put it here, increase the pointer, and increase this counter. And finally, we will take this element and put it here. After that, increase the counter, and simply we have to move till that position. So for the first time when we will start traversing this nums array, so we have to move from n minus k to uh, n minus 1, that is the length of till the length of this array. So we will move from this position to the last, and in the second iteration we will start from the starting from 0 index and we will move till n minus k minus 1 position. So finally we will get our final result. So if we will try to uh, analyze the time complexity and the space complexity into this solution, then the time complexity uh, is basically equal to order of n, that is linear time complexity, and the space complexity in this case is also equal to O of n, because we are taking an extra space which is equal to the size of this nums array. So this is our first approach. Let's try to write the pseudocode for this. So what we will do, initially we will take a counter which is equal to 0, and we will take a dummy array which is equal to the size of this nums array. After that, what we will do, we will simply start traversing from this n minus k position and we will go till last index and increase the pointer. And what we will do, we will simply take this element from here and put it in this dummy array. So we will simply put it as dummy of counter equal to nums of I. After that, we will simply increase this counter. Again, we will loop through this nums array, and now we will start from this first index. And we will go till this n minus k minus 1 index and I plus plus. And we will simply put these elements into this dummy array. After that, simply increase the counter. So this is our first solution. So this is the time efficient solution. Yesterday we have discussed one topic. We have discussed about time space trade-off. So basically we are following the same approaches to solve this question. Here it is time efficient. Now we will see space efficient solution where we will try to decrease the space, which will automatically increase the time complexity. So the second approach to solve this question is to make it space efficient. That means we are trying to decrease the space. So what we will do, in that case, we will not take any extra space. So this array we are taking to visualize. It is not the space, any extra space that we are taking. I'm just visualizing the final answer with the help of this array. So how we will approach this? So as we know, we have to rotate this array by k position, that is by 3 position. So what we will do, we will take an outer loop that will basically define that by how much time we have to rotate the array. So we will take an outer loop, and after that, what we will do, we will simply take this last element and extract it into a different variable. So what approach we are going to follow, let's discuss. So first, we will start from this and we will take this element out from it to a variable. So let's say we are taking temp variable here. And what we will do, we will store this last element into this temp variable. So this temp variable will be populated with this last variable, that is 7. Now this position is backend. So what we will do, now we will try to shift all of the element with one position. So after shifting it, this 6 will come here, 5 will come here, 4, 3, 2, 1. And at last, what we will do, we will simply take the element that we have stored into this temp array and we will simply store it at this place. So after this, this array will sorted. This array will be rotated for one time. Now we have to rotate this array for 2 more times. So what we will do? Now we will simply take this last element again and store it into this temp variable. So 6 will come here. After that, again we will try to move each and every element by one position. So after that, this 5 will come here, 4 will come here, 3, 2, 1, and 7. And at last, this position will be vacant. So what we will do, we will simply take this temp variable and put it at this place. So 6 will come here. Now our 2 rotation got completed. Again, we will perform the same operation. We will simply take this last element and put it inside this temp variable. So now temp is equal to 5 and try to rotate each and every element by one position. So after that, this 4 will come here, 3, 2, and 1. and this 7 will come at this place, 6 will come at this place. And as this first position is now backend, so we will take this temp variable and store it at this place. And after that, one more rotation is complete, and as we have to rotate this array by 3 position, so it is already rotated by 3. So if you will see, so this will be our final result. So after the final 3 rotation, after the final result will be like this. So this 7 after the final 3 rotation, it will come at this place, 1, 2, and 3. So 7 will come at this place, and so on. So this is the second approach, which is space efficient. Here we are not taking any extra space, but the time complexity is increased. So let's first try to write the pseudocode for this question. So our final array will look like 5, 6, 7, 1, 2, 3, 4. So let's write the pseudocode. So what we will do, we will take two loops. So first loop we are taking to track the number of rotations we are going to perform. So we will loop through it, I less than k and I plus plus. After that, what we will do, we have to extract the last element into a temporary variable. So we will simply extract the last element into the temporary variable. So temp equal to nums of nums dot length minus 1. After that, what we will do, now we have to loop through this nums array. So let's start looping through this nums array, and we will start this looping from this n minus 2 index and go till this 0 index. So let's start looping it. J equal to n minus 2, j greater than equal to 0, and j minus minus. After that, what we have to do is we will simply increase each and every element by one position. So what we will do, we will simply do nums of I plus 1 equal to nums of, sorry, it is not I, nums of j plus 1 is equal to nums of j. So it will what it will do, it will simply increase each and every element by one position, and this whole thing will happen for this k number of times. So we have taken this outer loop, which is tracking for the number of rotations, and for these number of rotations, this inner loop is basically traversing the array and increasing each and every element by one position. So this will be our final code. So this is the space efficient code, as we are not taking any extra space here. And now if we will try to analyze the time complexity and the space complexity of this solution, then the time complexity, as uh, we are using two for loops here. So the time complexity will be equal to O of n into k, and the space complexity is equal to uh, O of 1, as we are not taking any extra space to solve this. Now, if we will try to write this code and try to submit this into our, if we will try to submit this code, so this code will not get submitted. It will throw time limit exceeded. So why I am saying this? So let me explain this. So here, as we can see in constraint, it is saying that the length of this nums array will vary from 1 to 10 to the power 5. And the solution that got accepted always, the solution that got accepted basically ranges from 1 to 10 to the power 9. And as we can see, we are solving this in order of n into n, which is approximately equal to O of n square. So if we will do 10 to the power 5 squared, then it is equal to 10 to the power 10, which is exceeding the limit. of this 10 to the power 9. So that's why this problem, this solution will not get accepted, as it is basically exceeding the limit. So this is not the brute force approach. So now let's try to discuss another approach, which is the most optimal one. So our third approach will be the optimal one. So what we will do here, basically we have to rotate this for k times. So what we will do, we will simply come at this place, which is equal to n minus k, as n is equal to nums of length of this array, which is equal to 7, and k is equal to 3. So n minus k is equal to 4. So as we can see, this is the fourth index. So we will start from this index, and what we will do, we will simply rotate it. We will simply rotate this array. So how it will look like? After the rotation, the 7 will come here, the 6 will come here, and the 5 will come here. Again, we have to perform the rotation. Now we have to start from this 0th index, and we have to perform rotation till this n minus k minus 1 index. So we will rotate it from here to here. So after rotating, this will look like 4, 3, 2, and 1. And now once again, we have to rotate the whole array from starting from index 0 to index n minus 1. So when we will rotate this, so after that, the final result will look like 5, 6, 7, 1, 2, 3, and 4. As we can see, this is our final solution. So basically, we have to perform 3 rotation operations. First, we will start from this place, that is n minus k, and we have to go till this last position and try to rotate this piece of array. After that, we have to try to rotate the another piece of this array, and after that, finally, in the third rotation, we have to rotate the whole array. And after rotating it for 3 times, we will get our final result. So if we will talk about time complexity and space complexity in this case. So basically we are performing this rotation operation for 3 times. So time complexity will be equal to O of n plus O of n plus O of n, which is approximately equal to O of n, that is uh, linear time complexity. And as we are not taking any extra space, so in space complexity, we are solving this problem in constant space complexity. So let's try to write the pseudocode for this. So what we will do, we will simply implement a different function which will make us rotate the array, which will help us to rotate the array. So let's implement a function helper. What it will take this nums array. It will take from which position to which position we have to rotate this array. And after that, what we will do, we will simply try to rotate this from this position to this. So what we will do, orient, no, I'm sorry. What we will do, we will use a while loop here, and while I is lesser than equal to j, till that time we will perform this rotation operation. What we will do, we will take a temporary variable and store this nums of I in this temporary variable. After that, in place of nums of I, we will simply uh, store this nums of j, and again in place of nums of j, we will simply store this temp variable. So uh, this loop will perform this operation for this whole array, and after the final result, we will simply increase this I pointer as we are moving this I pointer forward, and simply decreasing this j pointer as this j pointer is continuously moving backward. So this is the function we have implemented. After that, uh, as we have to implement this rotate function, and it is giving nums and the number of rotations. So what we will do, we will simply take this here, rotate. It is taking this array and the number of rotations. So what we will do, first we will try to rotate this array from this n minus k position to n minus 1. So we will simply call this helper function, and after calling this we will simply pass this nums into it, and we will perform this operation from this n minus k index to last index. Again we have to call this helper function, and for the second time we will perform this on this part of the array, which is from 0 to n minus k minus 1. And at last we have to call this implementation for the whole array. So basically we will start from 0 and we will go till end. So this will be our final result. So let's try to implement this. So for this, first we have to implement a helper function that will help us to rotate the array. So let's implement the helper function. So it will take our array in two pointers. So basically this pointer will represent that from which index to which index we have to rotate the array. So what we will do, simply we have to move till this condition is violated, and we will simply expect the element into this temporary variable and try to swap the value so that we will increase the side pointer and decrease the j pointer. Here what we will do, first we will do k equal to k modulo 10, not 10, basically it is nums.length. So for this, let's extract the length of this array into a variable. After that we will do k equal to k modulo n, as I have made the statement that these both are equal, and I also proved that. So basically we will do k equal to k modulo n. After that, uh, we will simply call the function, call this helper function. And for the first time, we have to rotate it from n minus k index to n minus 1. That means from n minus k till last. We will do the same. We have to rotate this nums array. And for the first time, we have to rotate it from n minus k to n minus 1. For the second time, we have to rotate this array from first index to n minus k minus 1 index. And for the third time, we have to rotate the whole array. So basically, we will start from 0 and go till the end. And as we can see in constraint that this length of the array is varying from 1 to 10 to the power 5. So basically we have to handle the base case also. So simply handle this base case here. If n is equal to 1, we will simply return the exact array, the same array. So now let's try to run this. And it is accepted. Now submit this. Okay, it is accepted. So that's all for today. Thank you.